1, 2, 3, 4 electron domains. What would be the hybridization? Finger thumb rule. Start with your thumb. It's the S. Always put the thumb up first. I need to get to 4. 1, 2, 3 more fingers in the air to get a total of 4 electron domains. sp3. Your thumb first gets the electron domain for the first one. If I need 2 total, 1 more finger in the air. That's a p1. 3 total, sp2. Fingers stand for the p's. If I need 4 electron domains, sp4, it's 3 more fingers in the air. sp3 is 4 electron domains. Finger thumb rules, oh my goodness, makes all this hybridization talk easy. sp3 hybridization, 4 electron groups. We just looked at that. If I have a central atom, that's carbon, sp3. 3 more fingers in the air. sp3 gives us 4 electron domains. And it truly is that simple. When I start looking at the combined molecular geometry, they start showing hybrid orbitals. What do they physically look like in terms of clouds? An S-shaped cloud is spherical. A P-shaped cloud is an hourglass. Combine these two pictures and we get a hybrid orbital. This represents 4 degenerate, which means of equal energy. sp3 creates what we used to have as an S, P1, P2, P3, or what we called PX, PY, PZ. But if I hybridize to create 4 degenerate of equal energy levels, originally an S and PX, PY, PZ, create equal energy levels, and we get this combined picture. So all a hybrid orbital means is that they are now degenerate, which means of equal energy. So back to our original thinking, if our energy level, S's are of lower energy than P's, we make them all equal. If an S originally is of lower energy, we promote the electrons. Notice they're between. An S is below, a P is above. Well, now the hybrid orbital lies directly between. It's more energy than an S, lower energy than a P. It's a hybrid of the two. In an sp3 hybridized atom orbital diagram, another picture of the same idea. Originally, an unhybridized carbon atom would have 2 electrons in the S sublevel, 2 more in the P sublevel, leaving an empty energy level. Who wants an empty bedroom in the house? Let's let them spread out. These 2 remained the same. These 2 were hybridized. If all 4 create bonds, again, if the carbon atom fills all 4 of these to create 4 electron domains, it's said to be sp3 hybridized. We need 4 domains. Your thumb is an S, 3 more fingers, sp3. Can't make it any easier than the thumb finger rule. Draw the orbital diagram for the sp3 hybridization of each atom. Well, here's chlorine. 3s2, 3p5 would be its normal configuration. And again, if I place chlorine around a central atom, 1, 2, 3, 4, 5, 6, 7 valence electrons. Chlorine, with its 7 valence electrons, will create 4 bonds. sp3, 4 domains. This gets just very simple if I use finger thumb rule. Here's oxygen with 4 domains. S2, 1, 2, 3, 4, 5, 6 total electrons in the outermost shell. It lives in group 6A. 2s2, 2p4, leaving 2 empty spots for bonding. If we create, instead of S and P, we create that tweener level, the hybrid orbital, all of equal energy, we create an sp3 orbital with 4 domains, sp3, a total of 4 fingers in the air, 1 being a thumb, sp3 hybridization. So according to the valence bond theory, bonding takes place between atoms when their atomic or hybrid orbitals interact. That's literally just an overlapping of orbitals to create a space to share electrons. To interact, the orbitals must be either aligned along the axis between the atoms or be parallel to each other and perpendicular to the interatomic axes. So, in other words, I can have them parallel or I can have them perpendicular. A methane molecule with sp3 hybridization. Here's carbon in the center, 1, 2, 3, 4 bondings. Methane is CH4. We would draw its molecular structure with 4 bonded pairs. 440 is its molecular geometry, tetrahedron. To get 4, we raise our thumb first for the S, 2, 3, 4 fingers to get 4 electron domains, sp3. The fingers are the P's, sp3 hybridization. Now in that, they're all single bonds. Ammonia with an sp3 hybridization, one of these would be simply a lone pair of electrons, 3 hydrogens bonded with a single bond back to the nitrogen. To get 4 electron domains, we get an sp3 hybridization. Back to talking about bonds and the way they align themselves in a geometric fashion. If we see a single bonds form are known as sigma bonds. They result when the interacting atomic orbital points along the axes connecting two bonding nuclei. S to S orbital overlapping is a sigma. A P to P orbital overlapping is a sigma bond. Hybrid to hybrid, hybrid to S, any type of single bond where a